Hi, welcome to another edition of Numero Studio. In this video, we will talk about truth tables. A truth table is really just a neat way to show how the truth or falsity of a compound statement depends on the truth or falsity of the simple statements from which it is constructed. So what we are saying here is that a compound statement may be true or false depending on the kind of combination of the truth value of the simple statements that it is made up of. Alright, so what are these combinations? So for example, we have two simple statements P and Q. So we have those two propositions. For P, there are two possible truth values, right? So we have true. This can either be true or false. So we have two possibilities. For Q, we also have the same number of possibilities. So by the fundamental principle of counting, we simply multiply all these two. So we have 4. Now, what are these 4 combinations? So in order for us to not leave anything out, what we can do is divide 4 by 2. And so we list down the true first, so two truths, and then 2 false. And then for the next column for Q, so we do it alternately. Right. Now, what if we have 3 propositions, P, Q, and R? How many possible combinations can we get? So using the same fundamental principle of counting, we know that we have 2 possibilities for P, 2 possibilities for Q, and 2 possible outcomes for R. So we multiply all these 3 and we get an 8. Now, how do we list down all those possibilities to make sure we do not leave anything out? So we start by dividing 8 by 2, and so we get 4. So that means we list 4 truths first. So 1, 2, 3, 4, and then the next 4 will be false. And then for the Q column, we divide 4 by 2, and so that's equal to 2, and so we have 2 truths and 2 false, and then we do that alternately. And for the last column, we simply write down true and false alternately. True, false, true, and false. So doing it in this manner, we are guaranteed that we are not leaving anything out. So we are listing all possible combinations. Now, let's start with negation. So what does a negation do to a statement? This is pretty straightforward, because what a negation does is it simply reverses the truth value of a given statement. So that means if a statement P is true, it becomes a false, right? But if it is false, the not P becomes true. Next is the conjunction, a conjunction P and Q. So this is only true, so this is true if both P and Q are true. As in the case of the statement below, an irrational number is non-terminating and non-repeating. So for a number to be irrational, it has to be both non-terminating and non-repeating. So if it is non-terminating and non-repeating, that is an irrational number. If one of these properties is not present, it is false, meaning if it is repeating, even if it's non-terminating, it's still not an irrational number. Now, what if it is terminating and non-repeating, as in the case of f and t, it's still not an irrational number. What if both are not present? All the more that we consider it a false statement. So again, for a conjunction, it is only true if both p and q are true. Now, for the disjunction p or q, so by definition, p or q is false, right? Only when both p and q are false. So this compound statement p or q is false only when both p and q are false, as in the case of the statement given below. I will answer. So there's a missing word here. So I will answer the skills check either at 10 a.m. or 4 p.m. So in this case, if you answer it at either 10 a.m. or 4 p.m., this statement is true, right? What if you simply answered it at 10 a.m. and not 4 p.m., as in the case of true or false? It is still a true statement. What if you did not answer it at 10 a.m. but answered it at 4 p.m.? That is still a true statement. What if you did not do both? That becomes false. So see, it's false only when both p and q are false. Next is the conditional. The conditional if p then q, by definition, is false only when p is true, but the q is false. Now let's take a look at the statement at the bottom for this statement to make more sense. Say, we were given the condition, if you submit the assignment, then you will pass the subject. Now, what if you indeed submitted the assignment and you passed the subject? Then the conditional is true. What if you submitted the assignment but you did not pass the subject? So that's not what the condition was saying, right? So it's a false statement. Now, what if you did not pass the assignment or submit the assignment? Is it automatically saying that you will not pass the subject? Well, if you did not submit the assignment, you could still either pass or fail, right? So these two statements could still be true. So in symbolic speak, in logic speak, you call these two statements as vacuously true. Alright, next is the biconditional. So in a biconditional p, if and only if q, so this statement is true only if both p and q have the same truth values. Alright, so let's take the case of an angle is right if and only if it measures 90 degrees. So if an angle is right and it measures 90 degrees, it's a true statement. But what if an angle is right and then it doesn't measure 90? It's a false statement, right? Now an angle is not right and it measures 90 the entire statement is false. But what if an angle is not right? Then it doesn't measure 90 in the case of a false and a false propositions here. It's still a true statement. Again, an angle is not right and it doesn't measure 90. It's a true statement. To summarize, let's fill out the table here and see if we remember those definitions we just discussed. So, if we have the propositions P and Q, the not P would show false, false, true, true. For the conjunction P and Q, remember that for conjunction, it is only true when both P and Q are true. If you see a false, then it's false. So this is true and true, this is true. All the others will have to be false. For disjunction, it is only false when both P and Q are false. Right? So this is only false when both P and Q are false, meaning if you see a true, that becomes a true. When one or both are true, the entire conjunction is true. What if we have a conditional? The conditional is only false when you have a true hypothesis but a false conclusion. So meaning the only time that it is false is this: true going to false. All the others will have to be true. Now lastly, for P, if and only if Q, by definition, this is only true, or this is true only when both P and Q have the same truth values. So a true and true here is true. A false and false here will also be true. The rest will have to be false. So now we are ready for some examples. What if we were told to construct a truth table of if Q, then not P? And I think it is pretty straightforward that we cannot find the truth value of these statements without first finding not P, right? So we do not P first, so this becomes false, false, true, true. So what is going on here is we are reversing all the truth values here. These are the values. Now we can do Q, if Q, then not P now. Right, so we're talking about this column and this column, and we are using the conditional as an operation. Remember that in a conditional statement, we only get a false statement if we are coming from a true going to a false statement, which is the case of our first row. So this will have to be false, while the rest are true statements. Now, what if we wanted to construct the truth table of this compound statement? Notice that we are given with three propositions, P, Q, and R. So how many possible combinations do you think we will get here? If you said there's 8, then you are right. We apply what we learned earlier in finding all the possible combinations of 3 propositions. Now, what are the columns that are needed to be constructed for us to be able to complete the truth table? So the parenthesis here acts like a grouping symbol, which means that we have to do it first. That means we have to do the conditional first before we do the and. So in order for us to construct this, we need not Q. After which we can now do the conditional P, not Q. Alright, so for not Q, we will simply reverse all these truth values in this column, so that now becomes F, F, true, true, false, false, true, true. Next, we apply the principle or the definition of the conditional now. So from this column, P, conditional, not Q. Remember, for a conditional, it is only false if we're coming from a true going to a false statement. So this will have to be false. It's a true going to a false. False for the next column. This is true because it's true, true. And then true, true is true. Alright, so we begin with false statements over here. So we know that all these will have to be true. Now we are ready to construct the last column, which says that P, if P then not Q, or R. So basically what we are doing here is this column, P, if P then not Q, and this column. So we are applying the principles or the definition of conjunction. So if we go back, if we say conjunction, it is only true when both P and Q are true. So they have to be both true for us to say that they are true. So in this case, we're seeing an F in the two columns. So this is false, false. So true, true is true. False, true is false. True, true is true. False, true is false. True, true is true. And then false, true is false. So this is now the complete truth table of this particular compound statement. Now, what if we don't have the grouping symbol as was present in the previous example? What do we do? So there is actually an order of precedence that needs to be followed when there are no grouping symbols or delimiters shown. So the grouping symbols parentheses, the braces, or the brackets are otherwise called as the delimiters. So in situations like these, we use the order of precedence to determine which operations will have to be done first. Of course, it goes without saying that negation should be done first. Next is the conjunction and disjunction second, and lastly we do the conditional and biconditional, which means that if we apply the order of precedence, the conjunction comes first or will have to be done first before we do the conditional, which means that in the columns we need the not Q and then combine not Q and R before we can do the PRO, not Q and R. Alright, constructing the truth table, we have false, false. We are negating all these truth values. So this is true, true, false, false, and then true, true. Not Q and R are columns. So the columns for not Q and R are these columns. And we will apply the AND. So what's AND again? It's only true when both statements are true. So this is false, false, true, and true is true. There's a false, false, false. So all the next three statements are false, and then both are true here, so that's a true. And then there's a false here. this is false. And finally, we can now construct the if P, then not Q and R. So we will perform the operation, the biconditional operation on, the conditional operation on this column going to this column. It's a conditional, so again, in a conditional, it's only false. It's false when you're coming from a true statement going to a false statement. So therefore, this is false. It's true going to a false statement. True going to false is also false. True is true. True false is false. And since all these starts with a false statement, all of them will be true. Alright, that's about it for truth tables. Thank you for watching this video. Don't forget to subscribe and get notified for the next videos. See you in the next one.